after me. Do y'all know if there's anyone teaching after me? There is? Okay. So I'll just wait here. Oh, Isabella's here. Okay. Awesome. Hey, let me make you the host and I am out. Wait, hold on. Oh, there we go. Make host. All right, you're host now, right?
Yep.
Okay, I'm out. Good luck.
Okay, hello everyone. Good to see you guys. Just some housekeeping things real quick, but while I start sharing my screen. Um, so you should have seen the new thing about the point system, so it will now behoove you to do your homework. You can't chat right now. It's time, it's time to, cause, time to teach. So I think I'll start by talking about um what I will start by talking about the last time's homework. I won't go over everything, but I will let the people who got perfect scores know. But I want to talk about the whole dash rule thing and the reason why I didn't put it. It worked. Okay, so the reason why, so I won't talk too much about dashes especially since today is math day and not English day. But I have a thing that I like to call rule of twos, and that's if there's a dash earlier and the sentence is not ending anytime soon, then you can expect to see another dash. So the answer to this one was actually B. And I realized I didn't discuss it, so I went ahead and changed everyone's answer to correct on that one. So sorry about that. That was kind of my bad, but that's the rule of twos. If you see a dash earlier and it's not near the end of the sentence, there will be another dash because generally you put dashes around hunk of information. So you have like info and then you have another dash. Or you have like comma and then info and then comma, that sort of thing. But anyway, I won't linger on that too much. Just a little heads up. Sorry for not discussing it last time. I realized that let me check the chat real quick. No, I won't give you guys chat. Okay, so let's talk about okay, so blah. Um okay, so ACT math. So first of all, I want to congratulate the people that got a perfect homework. So the ones that actually did put their first and last name, I'm sorry for not like clarifying that, but Owen Zhang, Kevin Qian, Chloe Zhang, Delbert Nie, Rohan Pavluri, and Brenda Mao. You guys all got a perfect score on the homework, and as a result, you will get some points. If you don't know too much about the points, then check your email for like some pre. There was an email sent about the point system. You can use them for like little special rewards. And then there were also 4 kids who didn't put their last names, but I will list them here. You should be able to check to see if what you got. Ivy, Derek, Frank, Meenakshi. If you would like to redeem your points, put your name, put like your full name, like your first and last name in the chat so I can like write it down and then I can give you your points. Unless, of course, you're not here, in which case sucks to be you. Okay, Ivy Dong. Okay, nice. Congratulations. Savannah. Gotcha. All right. The homework is in the Google Classroom, and I don't have the Google Classroom like code with me right now, but it's on the Kid Teach Kid website. I can pull it up after, like if you want to wait until the end of class, then I can just like put the link. If you didn't get full scores, you will get points, but you get like an extra bonus if you get perfect. So do your homework. It is good for you. Also, I should probably any homework assignments that like come out now, then I won't grade them because like you should be doing them for the week. So, Frank, Derek, if you guys are here, you should probably drop your names. Otherwise, I won't be able to like give you your points. But you know what? We have to work. So So, basic information about the ACT math section. This one I didn't put it in the slides, but it is 60 minutes and 60 questions, so it is pretty time intense. You are allowed a calculator for this portion. I believe there are some limits to which calculator. Like the big one is that it can't have a QWERTY keyboard, but other than that, if you have like something like a TI, this is mine by the way, then you are good. You should use it liberally. Don't crutch on it too much. It is really handy for anything with a lot of computation. Formula and definition knowledge is useful, but it's not the basis of the test. It is more important for you to reason mathematically. So here are the 5 areas that you'll be tested on. And basically, if you're familiar with like the school math stuff, then basically it goes up to pre-cal-ish, and some statistics knowledge. I am not totally sure. I would probably have to glance at like the requirements for calculators. I could get back to you on that. So some statistics knowledge is pretty good, but it's not too much. Other than that, it goes up to pre-cal. So there are 5 areas that you get tested on: numbers and quantities. So basically, I won't go too much in depth about these, but you have like real and complex numbers, exponents, vectors, and matrices, systems of equations, graphs, word problems, linear, radical, piecewise, polynomial, logarithmic functions. If you don't know all of those, then like it's totally fine. Translation, locating important features, area, surface area, volume, some basic trig, and counting and center spread, model relationships. That it's a lot of words, but it is not as bad as like it might seem. So that's just like the basic info. So all right, so here is where I will dump some formulas. And there are a lot of these. So if there is one that particularly, but the thing is, there are a lot of formulas, but I would wager that you guys would probably know like at least like a third of them, if not more. Like, especially for those of you who are a bit more advanced in like math stuff, then you'll definitely be like very familiar with like, if not all of these. But if there is one that you have a question about, like in terms of application, then just like drop it in a chat and I'll be happy to talk about it in depth. But otherwise, I feel like if I were to talk about every single one of these, like we would have no time to get to actual problems, which is, in my opinion, more important than actual formulas. So I'll just talk about lines quick. If you have, okay. Taylor series will not appear on the ACT, so nice try. So if you have x1, y1, x2, y2, the slope of the line between them will be y2 minus y1, x2 minus x1. Slope-intercept form is y equals mx plus b, where m is going to be the slope, b is going to be the y-intercept. Straightforward. Midpoint formula. You have 2 points, x1, and you have y1. You have x2, y2. If you want to find the midpoint between them, all you do is you take the average of these. I can upload it to the website, so yeah. And then the distance formula is you have 2 points x. No, I want to erase. Bruh. Okay, you have 2 points x1 and y1 and x2 and y2. You want to find the distance between them. You take the difference of each, take the sum of the squares, and then you take the square root. This one is fairly intuitive if you know the Pythagorean theorem, which I would wager like pretty much all of you guys do. So I don't think these are too bad. I'm not getting any questions either, so let's continue. Where is the thing? Okay. Okay, percentage and statistics. If you have like a set of numbers, you have like A1, A2, all the way to AN. You have n terms in this. Then the mean or average of this set of numbers is going to be the sum. This is just the arithmetic mean, by the way. You don't need to know the other means. Average speed, total distance. total time, average speed. They like to test about this. Probability, this is one that you don't really see in class, but it's pretty common in like contests and stuff. The probability of an outcome, this is number of desired outcomes over total outcomes. So like if you have like a red ball, a green ball, a yellow ball, and a blue ball, and you want to draw the green ball, then the total number of desired outcomes is 1, and you have 1 in 4 chance. That one is not too difficult. X percent of n. That would be x over 100 times n. N percent of n. Same thing. I don't know why I put it twice. That's my bad. What number is n x percent of? So what number is n is equal to x 100? Wait, no. It would be 100 n over x. It's basically what number is n x percent of, like a different number. Again, these aren't too bad. Let's keep going. So some geometry things. Area formulas, I don't think I need to go into. So you have a triangle. You have the base times the height. Area is 1/2 base times height. You have a rectangle. Length, width, base times width. It's the area. Trapezoid. Base 1, base 2. The height. The area is equal to base plus base 2 over 2 times the height. And parallelogram, I guess I can talk about this one. Height, length times height. I should probably talk about circles as well. Oh yeah, you won't have a form. You might have a formula for actually. I'm not totally sure. Yes, that is the Heron's formula. Very handy. How many people are there? There are like 90. And then circle. This one's pretty straightforward. Area of a circle is equal to pi r squared. Neato. Okay, so now let's talk about right triangles. There are 2 special right triangles that I do want you to memorize. One of them is the isosceles right triangle. And that will have 45-degree angles. And then the lengths will be x times the square root of 2. The other type of right triangle that you should know is this one. It's called the 30, 60, 90 triangle. It will have side lengths x times the square root of 3, and 2x. And then, as you know, for a general right triangle, you have x. Oh, actually, I think it's a, b, c. That's how it usually goes. And then Pythagorean theorem states that a squared plus b squared equals c squared. Okay, last I'll talk about volume formulas. These aren't terribly interesting, though. You have like a cylinder. The area is equal to the radius pi r squared times the height. If you have like, if you have a question, you can put it in the chat. If you have like a pyramid of some kind, like it doesn't matter what kind of pyramid. It could be a square pyramid like this, or it could be a tetrahedron, or it could be like, I have no idea what this would be called, but it is a pyramid. You have one of these, doesn't matter. You find the area of the base, which is like whatever face is like on the ground. I'll denote it as A. That's the area of the base, times the height divided by 3. And then let's do 2 more. Oh, I guess rectangular prism. Or prisms in general. They're based pretty much the same. Rectangular prism, area is length times width times height. Actually, I've horribly mislabeled those. Length width, height. Ow. I don't know where I got that. Oh my God. Just ignore that. And then for the area of for the volume of a prism, you just find the area of that base and the height. So just the area times the height. And then one more, I'll put this a sphere. This is how I draw spheres. There will be practice problems. I am just like dumping you guys with formulas so that just to avoid like any confusion. Oh my God, who is? Okay, sorry for like the pinging sounds. What the heck? Who was that in the background? That was my brother. Give me a second to mute my messages. I don't know who is talking. Yeah. Okay, perfect. So the use substitution is a calculus thing. You will never use calculus on the ACT. I do think that some harder tests will use them. And the volume of a sphere is 4/3 pi r cubed. Oh, I should probably talk about cones too. Cones, it's pretty much the same as a pyramid. It's basically a pyramid. You find the area of the base, pi r squared, you multiply it by the height, you divide by 3. There is a calculus explanation for why it is over 3. Yes, there is trig. I will talk about it in a second, but it was pretty basic. Okay, so no questions about the geometry. Let's move on. I'm aware that I'm going kind of fast, but these are just what is on my base. Miscellaneous. Wait, what? I think I skipped over trig. The trigonometry formulas. So trig will only be relevant when it comes to right triangles. So let us draw this beautiful, beautiful right triangle. Actually, you know what? I will make it even more beautiful by drawing actual lines. Wow, guys, I am going full out. This is amazing. Look how good that is. I am proud. So I'm going to go ahead and label it A, B, C, and B is a right angle. And furthermore, just as actually no. Oh, okay. I might just be weird, but I like to label it like this because generally when you're labeling your sides, you have like A, and then you have a B, and then you have C, and then yeah, this is a right angle. So let's talk about trig. So your trigonometric functions are functions that are applied to your angles. Hi. Shut up. Yeah. So let us call this angle A. So the sine of angle A is equal to, so, okay, actually, I'll back up for a second. The mnemonic I want you to remember is so, ka, toa. Basically, what it means is the sine of an angle is equal to the opposite, O, over the hypotenuse. Hypotenuse is the long side. So sine A will be A over C. Ka is adjacent over hypotenuse. Adjacent is the side that is like right next to it. So cosine A is equal to B over C. And TOA is opposite over adjacent. So tangent A is equal to A over B. It is worth noting that sine A over cosine A is equal to tangent A. Couple other things to note. Sine squared A plus cosine squared A is equal to 1. I mean, this is pretty easy to show. If you have like A over C squared plus B over C squared, you have A squared plus B squared over C squared. By the Pythagorean theorem, that is just equal to 1. Don't clog up the Q&A section. I want to keep that to like actual questions. Yeah. So this is important to know. Sine squared A plus cosine squared A over 1 is equal to 1. Sorry. And then I will talk a little bit about let's do like let's do secant, cosecant, cotangent. These will never appear, by the way. These will probably never appear, but just in case they do, and also it's just good to know cosecant is equal to 1 over sine, which is just going to be c over a. Secant is 1 over cosine a. It's going to be c over b. Cotangent a is going to be 1 over tangent. It's going to be b over a. That's literally all you need to know. It's very, very rote. Just remember SOHCAHTOA, and you can like pull the rest from there, I think. Kevin, if you would, I am not talking about calculus in this class. Please stop asking. Thank you. All right. So in that case, let us go on to just like these two miscellaneous ones. We have a quadratic formula, which I think we all know. You want to find the values that make this equal to 0. That turns into x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, sure, you can leave. I don't care. Trig proofs? No, you won't. These are all multiple choice. Don't worry about it. Logarithms. So you have log a over b is, let's say that. This, if you've never seen a log before, don't worry about it. This basically comes from a to the x is equal to b. And there's a lot you can do with that, but we won't be talking about them too much. Okay, let us move on to practice questions. Okay, so now with that out of the way, I have finished dumping you with practice questions. Okay, so here, have fun. I'll give you guys like a few minutes. Adding and subtracting logs. I will probably talk about those like a little bit, but they're logarithms. Like they're weird. They only appear like once. If you ever see a log question, there will only be one log question. Like I have yet to see like one that has like multiple logs. So I'll give you guys a few minutes to do these. Feel free to drop your answers in the chat. We're doing these three practice questions. Submit your answers in the chat. I don't know how to make polls. Okay, let's go ahead and talk about these. So 4% of 1100, it's going to be 4 over 100 times 1100. I think that's like pretty straightforward. Good warm-up question. D. I'm pretty sure everyone got that one too. So, slope of a line. Slope of the line formula. You take the y-coordinate of this, and then subtract the next one. Take the x-coordinate of this, subtract this. You have 10 over negative 5. It's going to be negative 2. And now, number 3 is where I saw a lot of people slip up. Remember that the sine of angle A, that's going to be opposite over hypotenuse. This is going to be 6 over 10. It's going to be 0.60. C. So for those of you who put D, C, you are correct. Nice job. Okay, so I'll give you guys 2 word problems, and then we're going to actually move on to some harder ones. So these 2 are a bit more tricky. Oh, I don't know why. I forgot to change the answer choices. Okay, it should be. I'll go ahead and just replace them. F and F. So I don't know why I have an A. That's just a typo. By the way, this is where having a calculator is pretty good. So you should get out a calculator if you haven't already. You're not going to be able to do the second one if you don't. I don't know why, but like ACT never puts I as an answer choice. Like I think they don't want to mix it up with one. No, it's not unlucky. It's just that I think I is very easy to be mistaken for one. So like if you have I here, then it could be taken as like 1.50. I don't know. It's just some weird convention. It could just be, sort of like a 13th floor thing. Like, oh, we don't put a 13th floor here. I will start discussing these in just a moment. I want to just like make sure that everyone has done them, or at least whoever is paying attention. Okay, so let's talk about these. Um, So we know that the distance for this is 200, and she completed this at 10 miles per hour faster than her normal speed. So let's say that her normal speed is x, and then that her usual time is t, or not t. So the normal time she would take is 200 over x, oh, in hours. And then if she goes 10 miles per hour faster, then multiplies by 200 over x. It's also going to be 200. 200, my bad. 200 over x minus 1, because it's going to take one less hour than usual. And in this case, we can just FOIL it out. So just like multiply. I might make, by the way, there's a moderate chance that I'll make like an arithmetic mistake here, so bear with me. At this point, like you can pretty much try and see what would work here. So I believe it would be, if you put in 50, get 50 minus 40 minus 10, so 0. So I think it'd be J. Wait, I might have made a mistake. Yeah, my bad. It is actually just 40. I'm not totally sure where I made the mistake, but just checking. Oh yeah. That was my bad. I accidentally swapped the signs, so it'll be 2000 x minus x minus 10 is equal to 0 instead of x minus those. I'm not sure what I was thinking. Thank you for the catch. Yes, it is 40. Nice job. All right, so the next one is going to be an application of trig. Um, you want to find this length, which I marked with a question mark. So it's going to be sine. So if you remember your trig identities, of course, it would be sine 20 is equal to the opposite over hypotenuse. And you know sine 20. If you don't know sine 20, you could just plug it into a calculator. We'll just mark this with a question mark over 500. Then you whip out your calculator. Make sure you are set to degrees, by the way. You don't want to do sine 20 radians. That will get you the wrong answer. The sine 20 is equal to about 0.34 multiplied by that by 500, and you will get around 170. So it's going to be G. Oh, of course, if you want, you can realize that this is equal to 70 degrees, and you can do the same thing with cosine 70, but I got news for you. Sine 20 and cosine 70 are equal. So. Okay. Um, let's move on to, all right, we're actually going to move on to like the harder questions. So these are definitely going to take a while, and I don't think these are the sort of question that you'll see in like school class. If you take like a competition math class, or something else like that, then you probably will. So you do not have to worry about this tens digit part unless you are really, really, really bored. And if we actually have free time, I can tell you how to tens digit. Um, but these are a fair bit trickier, and don't feel discouraged if you find them like kind of hard. Ooh, nice, nice human. The answer is 6 for the tens digit. That's nice. Ah. Oh, I thought it was just you. um. Oh, I have no idea what your name is. Sorry. Oh, Benjamin. In that case, if you want me to call you by your name to rename yourself, that would be cool. Um, I don't know you. Sorry. Okay. Let's go ahead and talk about these. So, the first one is a matter of like pattern find pattern find. So obviously you can't find you don't want to find this number. Your calculator won't be able to display it properly anyway. By the way, you guys want to know answer EAT. Cool. Um, so if you want to find the ones digit, all you need to worry about is the last digit. Um, I would, but here, rename. I'll name it. There we go. Fix your name. Okay. If you want to find the ones digit, all you need to worry about is the last digit. So you have 537, ends in 7. Multiply it by itself, 537. What's it going to end with? It's going to end with 9. 7 times 7. Yeah. Multiply by another 537. 9 times 7 just gets you 3. And then you multiply by another 537, and you'll end in 1. And anything multiplied by 1, you just like get itself. So when you multiply 537 again, you're going to end in 7. So basically what you're going to have is 537 to the 1 is going to end in 7. 537 squared is going to end in 9. 537 cubed, give me just a moment. 537 cubed is going to end in 3. 537 to the 4th is going to end in 1. And it's going to repeat. Actually, this is a really common thing. So you'll end in 7, 9, 3, 1. If you're bored, you can find what the cycles are for anything that ends in 2, 3, 4, 5. Well, actually, 5 is not interesting. It just repeats itself. 6 as well. I already told 7, 8, and 9. Those are just if you want those for fun. So yeah, it repeats every 4. So you have 102 is going to give a remainder of 4. Or is going to give a remainder of 2 when divided by 4. So it's going to be the second one. Cool. All right, the next one. I should just clear the drawing. Yeah. So let's solve for n. All right, this one's a little tricky because you can't actually like isolate n. Yeah, it's equal to 9. Yeah, I actually don't know what the hundredths digit is, and I can't calculate right now. But yeah, so it's not very easy to like isolate n, because let me think. It's not that easy to isolate n, unless you use logarithms, and honestly, don't use logarithms. So let's look at this thing. So if you know square root, when you take the square root of something, essentially what you're doing is raising it to a fractional power. In this case, since it's a square root, it is 1 over 2. So you have 5/4 to the power of 3/2. That's just by power exponent rules, 3 times. And you have so you have 4/5 to the power of n is equal to 5/4 to the power of 3/2. And then something interesting to note is that when you raise something to the power of -1, what you're doing is taking the reciprocal. So this is just like more based on like exponent rules that you hopefully learned in class. So in this case, it's going to be 4/5 to the power of -1, then 3/2, which is just going to turn into -3/2. So that's going to be A. Cool. I need a bigger eraser. Okay, and last one. For this one, there are a couple ways you can do it. Either you could just try all the solutions, and then you'll get D. D is the correct answer. Either you could just try all of them, but that is kind of a waste of time. So I would personally recommend what you do is you can take the least common multiple of 6, 7, 8. That's the smallest number that divides all of each of those divides into. And then you just add 1, because then you'll be guaranteed to have like 1 as a remainder. So what is the LCM of 6, 7, 8? Well, you can find that by looking at their prime factorizations. 6 is going to be 2 and 3, 7 is just going to be 7, 8 is going to be 2 times 2 times 2. And what you do is you find all the 2's, so you see there are 2 2's in the 6 and the 8, and then you just like eliminate one of them. So then you take the remainder of these, 2 times 2 times 2, take the 3, take the 7, and when you multiply them all out, you'll get 168. And then for the remainder, you just add 1, that's 169. Nice. Okay. This is my, this is the next set of questions, and I have one more set of questions that are like ultra hard. I don't know if they're like super duper hard, but they are probably the hardest ones of this set, but here are a couple more. So have fun. Okay. Let's talk about this one. So, I think the tempting answer is just to put 10, but it's not 10 because directions are a thing. It's not just 5 plus 4 plus 1. Um, so let's say that so a good idea is to draw a good diagram. So, 5 miles to the east, I'll be like this. Okay, so this is, I'll briefly draw like where I think the directions are going to be. So this is going to be north, south, east, west, and then everything like in this direction is going to be up and down. That is just my best try at drawing a 3D coordinate thing. So let's start with um, non-objective. So this is going to be the station. Let's see, TS. 5 miles to the east, this way, so it's going to be 5. Then 4 to the north, up here, and then 1 mile above. So it's going to be here. And then how do we calculate this distance? The thing is, you can actually kind of write this as like a rectangular prism. So you have 5 this way, you have 4 this way, you have 1 up here, and then you're just kind of climbing all the way up. And the way you calculate this is with the Pythagorean theorem, yes. But it's a little tricky to apply the Pythagorean theorem in 3 dimensions, so here's just a quick tutorial how. So first, we consider the one, let's consider like down here. The distance this way is going to be calculated with the Pythagorean theorem. It's just going to be the square root of 25 plus 16. That's going to be 5 squared and 4 squared. And now we account for this right triangle, the one that's formed by this diagonal line and this height 1 and this. I realize I've kind of made it really ugly, but that is 1. So this side is going to be the square root of 41, and then this one's going to be 1. So when we want to find that big diagonal, I think I've heard it called the space diagonal. It's going to be square root of 41 squared plus 1 squared. Take the square root, and it's going to be square root of 41 plus 1, which is going to be square root of 42. Plug that into a calculator or use your best approximation skills and just get 6.5. Oh, I think the actual answer is like 6.4 something, something, something. If you have any questions about that, just let me know. Okay, which of the following line graphs shows the solution set to this inequality? So how do we normally solve these? The way that we do it is this is an absolute value sign, which basically means the distance from 0. And either that's just the number itself, so like x minus 5, or that's equal to the negative of it, in this case, like 5 minus x. So we solve both of those. So first we take x minus 5 is less than negative 1. And then that gets you x is less than 4. Note that there's going to be like an open circle. So that's one case. The second is going to be 5 minus x minus negative 1. Note that these two are disjoint. Like either one is true or the other. But you don't need to satisfy both. So 5 minus x is less than 1. When we do this one, you get x is greater than 6. So our answer is actually going to be J because you have to satisfy both of those inequalities. The question on the left, it's not 7.2 because the answer is the square root of 42, which is around 6.5. I'm not sure exactly what you did to get 7.2, but it is not. The absolute value is never less than 0, yeah. But when, wait, oh yeah, that's true. The absolute value is never less than 0. That is very true. I am actually like completely, I kind of missed that part. Whoops, I'm not sure what my brain was. Yes, the absolute value can never be less than, it can never be negative, so it is actually K. I'm really sorry. Yeah, big rip. Yes, it is K. Okay, that was a bit of an oof. Okay, let's move on to the final one, and this is our last set of 3. And yeah, good luck. These are kind of daunting. By the way, if you're not familiar with the term modulus, it's basically the same as magnitude, if you've heard it that way. So anyway, best of luck. And yeah. guess we're running out of time. So I will just go ahead and launch into these. So you can do this one with the quadratic formula. So it's x squared plus mx plus n. I guess, yeah. So let's do the quadratic formula. By that, we have m squared minus 4n all over 2. And this is going to be equal to -3. The thing is, with when there's only one possible value, that means that this is called the discriminant. It's going to be equal to 0. Generally, the rule of thumb is if this thing is negative, then you have no real roots. If it's equal to 0, then you'll have one real root. And if it's equal to something positive, then it will have 2 real roots. In this case, if there's only one possible value, then that means that this is going to be equal to 0. So we can just get rid of it entirely. So then that's going to be -m over 2 is equal to -3. M is equal to 6. C. Okay, the next one. F of g of x passes through 4, 6. That basically means this when you apply the function g and then you apply the function f, you'll get this for x is equal to 4, y is equal to 6. So the f of g of x is going to be the square root of, instead of having x, you replace it with g of x. You have 7x plus b is equal to 6. That's going to be y, and then x is going to be 4. So let's calculate what b is. So it's 28 plus b is equal to 6 squared, and b is equal to 8. Is our answer? Okay, last one. Basically the question is asking what a squared plus b squared is. And if you don't know where, yeah. So they basically describe the whole imaginary axis thing. Basically, you have a function a plus, if you have a complex number a plus bi, it's going to be graphed comparable to the point ab. So you'll have like, I'll write it as a5, b5, a2, b2, and so on and so forth, with all the subscripts being the same as that of the actual point. This looks really familiar. Where have you seen that before? Drop it in the chat. Oh yeah, of course you could just use Vietta's. Distance formula, yeah, that's good. Pythagorean, yeah. Yeah, distance formula, Pythagorean, pretty much the same thing. Yes, it's going to look exactly like the Pythagorean theorem, which basically means that you're looking for the point that is farthest from O, the origin. And you don't even need to know like where they are. It is pretty easy to see that the first one is going to be the farthest away. So it's going to be that. Okay, so that is going to be all for today. I will post like a homework assignment later today. And yes, of course, you could just use Vietta's on number 1. That works too. So that's all for today. A lot of people aren't too familiar with Vietta's, which is why I didn't want to bring it up. But yeah, thank you guys so much. I will see you guys next week. Oh yeah, I will get the code. Just give me one moment. Yeah. For those of you who don't know what the code is, it's going to be GVYYP5. I will post this to everyone. All panelists. There it is. So if you guys, yeah, you guys can head off. See y'all. And yeah, there is the code. GVYYP. It's also on the website. All right, I'll go ahead and end the meeting. Bye.